All right, so it's my pleasure to introduce the next speaker, Paco Nathan from Mesosphere. We'll be talking about how to run Spark on Elastic Mesos. I can give you some background on the Mesos project. Mesos means mediator in Greek. Don't ask why I know that.
In between.
And actually, Spark's initial goal was actually to demonstrate the power of Mesos. That was actually one of the main goals that we had when we built in the beginning, when we were doing Spark. So please.
Thank you very much. Hi, my name is Paco. I'm at Mesosphere. I'm also an O'Reilly author, I've been working in enterprise data workflows, but definitely taking a lot of look and paying a lot of attention to the Berkeley stack, writing and speaking more about that now too. So I've got 3 parts today. First off is to go through a little bit of intro to Mesos and some resources for how to learn how to use Mesos. Secondly, a real brief tutorial about how to get started in 5 easy steps of running Spark on Mesos. As mentioned, that's where Mesos originally started out, or rather that's where Spark originally started out, was running on Mesos. And thirdly, I want to talk about a project that's in progress. Myself and some others are working on integration for Spark for more enterprise kind of use cases. So the first thing here is about mesosphere.io/learn. It's a set of tutorials that we've written for how to run different types of frameworks on Mesos. So if you want to do a quick start to get going on Hadoop, it's a very short tutorial. If you want to do something more extended, there's how to package Apache Hadoop to run on a Mesos cluster. Also, of course, running Spark on Mesos, running Kronos, Marathon. I believe that Storm is coming up next. There's a few others, and some more integration too, of like how to build ETL pipelines with different components. Of course, this kind of raises the issue of why use Mesos. So let me ask, how many people here are familiar with Mesos? Okay, that's good. That's like 2/3 of the audience. Awesome. Usually I'm swimming upstream a little bit more. So one of the big issues, it was kind of funny because 2-3 months ago when I went and gave talks, everybody would ask, hey, why are you doing Mesos? Why not do Yarn? And in September, that stopped. And actually, I guess it was probably more like 3 months ago. So end of September, that stopped. And now more and more people are asking about sort of this open source perspective on what Google does to run their data centers. So Google has been using data center computing for a number of years to address a lot of issues. They don't use virtualization, they use isolation. They've actually contributed a lot of kernel mods to Linux for C groups, for isolation. And Google makes the point that, if you look at cluster traces, whether it's at Google or Yahoo or Facebook, or Twitter, very large-scale cluster traces will show that like 80% of the jobs are batch, but 80% of the resources or more are being thrown at services. You typically throw resources at services to get your SLAs. And that's where your utilization drops. That's where a lot of costs skyrocket. Google is known for having much higher utilization than most across the industry. So they haven't really published a whole lot about it, but there's a few things. I'll give some links. There's a great article called Return of the Borg that Cade Metz did in Wired last year. There's also a really excellent YouTube video by John Wilkes, who leads the Omega effort at Google. And more to the point, there's a paper called Omega about their research efforts. And one of the authors on that is Andy Konwinski here, the organizer for Spark Summit. And in this here, Google points out what they consider to be monolithic schedulers, 2-level scheduler, shared state scheduler. They would consider their several-year-old project Borg, which they run in production now, to be a monolithic scheduler. They would also consider Yarn to be a monolithic scheduler. Mesos is more in a class of 2-level scheduler as of when this paper was written. That was over a year ago. And now it's moving more towards some of the features of shared state, which is Google's research goal for Omega. And there's a really great Jeff Dean YouTube video about this too. I'll have these slides up on SlideShare. So Mesos became a top-level project in Apache this summer. And it's very configurable. You can get isolation for CPU, RAM, network, file system, but you can also use ad hoc resource tags to have isolation for, say, rack locality or dispersion across different racks, et cetera. And so we think of Mesos as being a distributed kernel. Marathon is an example of, you could think of it as like a distributed initd, or distributed upstart. So when the kernel boots, the first process that launches is initd. The first service that's launched is cron. So Marathon is like a distributed initd, and then Kronos is like a distributed cron. And from that, you can run a lot of different types of frameworks, such as Spark or Hadoop or MPI, et cetera. But then you can also run services, highly available services, such as Ruby on Rails and Jetty and whatnot. So there's a lot of production deployments, Twitter being very large, Airbnb, those are the two big case studies, but a lot of other very interesting companies too. And there's more than this that aren't public yet, but a couple that are coming public soon. And Chris Fry was actually in Wired, SVP of engineering at Twitter, was in Wired very recently talking about Mesos, about how it really powers a lot of what they're doing to scale out Twitter to get rid of the fail whale. Now the fail whale is deprecated. So I've got some resources here, and my research notes are at the very bottom, where I try to collect everything I can that's come out about Mesos. Okay, so next is Spark. First off, I want to show how to launch a Mesos cluster in 3 easy steps. So if you go to elastic.mesosphere.io, this URL, first off, choose what size of cluster you want. Secondly, put in your AWS credentials and a public key for SSH. And thirdly, give it your email, because we're not going to keep track of any of these credentials. We're just going to send them off on the wire. You need to have that email to know where your endpoints are going to be. And then you get an email that says, hey, you've got a cluster running, and the Mesos console is up at that first URL. There's also some different tutorials, the ones I've shown, that are pre-populated with all the IP addresses and different settings you need, so that you can actually cut and paste out of the tutorial into your SSH prompt. So we'll look at Spark. Now, in 5 easy steps, I will launch Spark. First off, log in to one of the masters in your Mesos cluster. Just SSH into any one of them. And then from there, just make sure you've got get and JDK. And then from there, we'll download Spark. And we've got 0.8.0 there that we're using. From there, we do an SBT clean assembly to build it. And step 5, finally, make your distribution, copy it out to HDFS, and set up your environment variables. And then, good to go. So that runs Spark as running Spark Shell. Now, thirdly, I want to talk about something vaguely related to the above. I've been working on a standard called PMML for a while, and I'm currently working on a project with some others on doing integration of PMML into Spark. And this is slightly orthogonal to what's going on with ML-based, but hopefully feeds into it, and hopefully could be contributed to it in some ways too. How many people have used PMML before? Anybody? Couple? Okay. So it's a standard that's been around since it was like 16 years. And a lot of the big financial players use it. FICO, in particular, is a really big user. But it's a way of taking predictive models and capturing the metadata, the workflow. Sort of think of like BPM or BPL for analytics workflows. Here I've got an R script that I wrote that it uses random forest to train a real simple anti-fraud classifier running through some customer orders. And at the very bottom, it takes the model and saves it out, serializes the model as PMML. And even though this is trained in R, now it could go and be scored somewhere else. The XML looks like this. I don't recommend humans reading it, but it does capture workflow. And so the interesting thing is that almost all the analytics vendors support this. So you can go and create models in SAS, export them as PMML, and then run them somewhere else. And there's a lot of great coverage in terms of the different families of machine learning algorithms, et cetera, that are used. You can also extend it. You can also do ensembles, model chaining, different types of segmentation. Okay, so there's a reference implementation for this in the Python stack. It's from, it's a project called Augustus, and it's Bob Grossman's team at Open Data Group in Chicago, and I do some work with them. Also, I wrote the original version of Pattern, which is PMML implementation for Hadoop via cascading. And so the gist of this is that we could take models out of, say, SAS or SPSS or some kind of legacy analytics framework, or for that matter, Oracle, MicroStrategy, and then bring them in to run in Spark. And there's a lot of great economics for that because SAS clusters are very expensive. And so one question I want to bring up is why would we want to do this and not just use ML-based instead? And well, one of the issues is that we really want to focus on PMML as a point of integration because you're not going to get rid of all the legacy systems for analytics anytime soon, especially if you're in regulated industries or audited industries. If you're in finance and you have an anti-fraud model that's written in SAS, try getting rid of that next quarter. It's not going to happen. So I think that for sake of integration of Spark for enterprise use cases, this is a very pervasive way to gain a lot for integration. And also, I mean, it's the kind of thing that as we provide more integration with different types of PMML support, it could be contributed into MLBase as another kind of connector. Alrighty, lastly, we've got a couple conferences coming up. We've got a Mesos workshop and talk and Birds of a Feather at Data Day Texas coming up in January, and also O'Reilly Strata in Santa Clara in February. We'll have a workshop and some other gatherings too. Thank you.
Questions?
Any
questions?
Okay, yes.
Wait.
So I believe, well, I know that Mesos has quite a bit of the straight point and much better in some things than Yarn, but basically Yarn is much more popular right now. It's becoming de facto standards.
Well, I think the people at Twitter would probably argue vehemently against you. Twitter's been using Mesos at scale for 2 years, and they have clusters that are 150K core. They do revenue apps on this. And Chris Fry is on record as saying this is how they scaled out Twitter for their IPO.
Okay, I'm very,
So your question.
I'm very glad for Twitter, but I'm talking about the whole industry.
Okay.
What do you think the future of Mesos, let's say in 2-3 years? Will it be the same niche product as it currently, or it will be
well, it's not a niche product.
Competitor of Yarn?
Okay, I'll let you finish. It's not a niche product. I would like to see the use cases for Yarn that would compete with what's already been happening for years with Mesos. And then number two, there are other large players. I'm not allowed to name them. Some of them will be coming public shortly. And I find that their use cases are generally considered to be thought leaders and other people follow them. So calling it a niche product is really a red herring.
Okay, thank you. Wait, one more question maybe. Okay.
Question is more like the PMML
Yeah.
with the ML base. Like the last MLab and a lot of meetup with Spark had a lot of interest on the ML based integration with Spark. And
Yeah.
what would you even consider maybe moving the integration PMML into ML base?
Yeah. No, I think it would. I think it belongs initially in Spark because I think that the kind of people who use this at scale right now are very conservative. My focus in O'Reilly is more enterprise data workflows, and the enterprise customers are probably going to be less likely to move to ML base right now, but eventually. And so this could be a great base for connectors for ML base. Another note about Mesos, just to be fair, large use cases for this would be Ruby on Rails. You're probably not going to run Ruby on Rails on Yarn. And when you get into low latency, like hedge funds, things like that, you're also not going to be using Yarn. So that's really more the case of this, is how can you increase your utilization and drop your latency.
Okay, let's thank the speaker.